Today we assess a regression model, and the way we do that is by looking at the residual plot that the applet makes us. So a scatter plot plots the residual on the vertical axis and the explanatory variable on the horizontal axis on that cool little residual plot. That's that graph that goes underneath the scatter plot that we originally graphed. It's called the residual plot. He can tell us a lot of cool stuff. And then once we get into a little bit more information, we'll hear some more vocab. The standard deviation of the residuals, they call that S. It measures the typical size of a residual. Remember, residual is like how far away you fall from the regression line. It's just like, oh, this was so far away. S measures the typical distance between the actual Y values and the predicted Y values. You might want to circle that, knowing what the homework looks like today. It's helpful that the standard deviation deals with the Y values, not the X values. And then finally, our last little vocab, the coefficient of determination. They call it R squared. It's just fancy little math talk. It measures the percent of the variability in the response variable that is accounted for by the least squares regression line. We'll start abbreviating the least squares regression line to look like that, the least squares regression line, because this gets tiring writing that puppy out. But remember, variability is the magic word on this R squared guy. The variability is how far spread out things are, how much they vary, right? So it looks like it's going to be complicated. Man, today is actually pretty darn easy. So here's a graph of the Super Bowl number, like whichever Super Bowl. We're up past Super Bowl 50 already. And the cost of a 30-second commercial for the years 1967 to 2020. And I'm sure you guys know, even if you don't watch football, that Super Bowl commercials are expensive, you know. So if you can kind of see the original graph over here, this is the scatter plot of that. And then what they did was they plotted that. They made a least squares regression, and then they made the residual graph. Question for you. Do you think that this line fits the original data very well? Yes or no? Like, there's no way. That's a curved pattern in that case. So the way you can tell, they say, is the least square regression model appropriate? Here's what you're looking for. On this graph, is there still a curved pattern, or is there not a curved pattern anymore? What do you think on this guy? Curved or not curved? He's curved. That's bad. Curved is bad. If there's a curved pattern, that's not a good, like, model. What they're saying is this line is not good. Like, that line does not fit the data the best. So the way we can tell that is to look at that residual plot, and if there's a curved pattern in it, that's bad, you know. That's bad because they're saying, like, these guys were way above the line, then these were way below the line, and then these were way above again, and it's not good. So let's try another one. Here's old data that we looked at before about that Ford F-150 way back from 3.5. It was just like how many miles it has been driven and the price you could sell it for kind of stuff. Would you believe that this original linear regression line, it looks much better than the one on this Super Bowl commercial one? It's like, yep, this guy seems to fit the data a little bit better. They say, is that least square regression line appropriate? By looking at this, this is that residual plot. Is there a curved pattern to the residual plot, or is it nice and spread evenly up and down in this case? That means there is no leftover curve pattern in the residual plot, so yes, that is a good model. That means that this line is pretty good. If by looking at that residual plot, there's no leftover curve pattern, that's a pretty good model then. It doesn't mean it's perfect, you know, but it's just like it's a pretty good model. Pretty good model. There's still extrapolations that could happen. If you remember back, I know it is a Monday morning, but when we said, what if that truck was driven 300,000 miles and then the value would be like negative $10,000? It's like, okay, that's an extrapolation, but this line does a pretty good job for the data that we have. So that's what it says in the gray box. You might put a star or something by it for when we take our quiz. It says, is the regression model appropriate or not? If there's no leftover curve pattern, that is appropriate. If there is a curve pattern, it is not appropriate. So curved is bad. So pretty basic. The cool thing is we've got the applet to do all of that graphing for us. You know, it's like we just got to read the graphs. And then finally today, we'll get into the standard deviation of the residuals and the coefficient of determination. It says, again, with that Ford F-150, we found a residual of this much. For it had 70-some thousand miles on it, and the actual price of this much. The price of the truck was this much less than predicted, based on the number of miles it is driven. Well, here's what all those crazy models mean. That you'll see on the applet, it gives us this S value, it gives us this R squared value also. The standard deviation of the residuals, this guy right here, to interpret its value. If we get an S value of 5,740, here's what that means. The actual price is this much away from the predicted. The actual price is whatever number they gave us, 5740, away from the predicted. And then I know it's first thing in the morning, but check out what I underlined. It's about price. Is that an X value or is that a Y value, guys? Price. It's about the Y values. The standard deviation of the residuals tells you about the Y values. So like that S value would be coefficient of determination, R squared. They say it is 0.66. We're always going to need to change this to a percent. So would you believe that 0.66 changed to a percent is 66%? Here's what that means. The coefficient of determination measures your variability. So 66% of the variability is accounted for by the least square regression line. 66% of the variability is accounted for by. They did some really cool math. And would you agree that this line right here, it's like not the strongest. Like the data doesn't fit the strongest to that line. So the math that they did, they say like 66% of the spread is accounted for. But that would mean like 34% of these dots are probably not in the best thing. So it's just like, all right, 66% of the variability. Let's try another one. Here's another least square regression line. They're measuring someone's height versus what they could do as a vertical jump in this guy. The standard deviation of the residuals is 4.45 inches. Interpret that value. So when we're doing that, we talk about the Y values, right? So the vertical jump. The actual, you'll say the actual Y value is number away from predicted. It's pretty much the same sentence every time. The actual Y value, in this case it's vertical jump, is number that they gave us away from the predicted. The actual vertical jump is 4.45 inches away from the predicted. So this S value is always asked about the Y's. The actual vertical jump is 4.45 inches away from the predicted. That's the standard deviation of the residuals. And then this coefficient of determination, we got to change it to a percent and talk about variability. So what's 0.29 as a percent? 29% of the variability is accounted for the least square regression line. So that takes us to this guy right here. When is S a good number and when is R squared a good number? The standard deviation of the residuals, the closer it is to zero, the better. Right? The closer that thing is to zero, like if you had a line that measured like, all right, this is what we're going to predict, and it was only $0 away from that, it's like, dude, that was very accurate. It was really, really close to it when that guy's close to zero. And then the coefficient of determination, that was the percent, dude. Well, it's got to be close to 100%, but 100% as a decimal is this guy. So what I'm going to let you do is I'm going to just take a small pause. I'm going to let you guys work together and try 7, 8, and 9, and then you can join me back on the video, but let's see what you think. This is a good guy. The residual plot is good because there's no curved pattern left. The dots are spread up, down, up, down, up, down, up, down, some way, which way. They just kind of vary from going above that residual line to not. So yeah, that was good. We've discussed this is not the real graph. This is the residual plot. Like these are real graphs, you know, like if you was to do the scatter plot on your applet, it's like here's the real graph. And then it plots that weird graph underneath it. That's called the residual plot, you know. So and then determine the S value of 1.21 for this model. S value of 1.21. The actual battery life, so we'll say actual Y value is number away from predicted. The actual battery life is 1.21 hours away from predicted. That's what an S value means, the standard deviation of the residuals. And then here's two things about this R squared. Change it to a percent and mention the V word. The V word is a variability. So what do you think? What would this be as a as a percent? 34.2% variability is accounted for by the least squares regression line. 34.2% of the variability is accounted for by the least squares regression line.